Today's episode is sponsored by Meter, delivering a complete network as a service offering, wired, wireless, and cellular in a unified solution. Find out more at meter.com/heavy networking. Welcome to Heavy Networking. I'm your host, Ethan Banks, along with Drew Conroy Murray. And you can follow us along with the Packet Pushers page on LinkedIn. And you can connect with us on the Packet Pushers community Slack group, too. On today's episode, a networking acronym many of you won't have run into, PCE, Path Computation Element. PCE, along with PCEP, Path Computation Element Protocol, is a way to construct forwarding paths through the network based on factors distributed routing protocols like OSPF can't take into consideration. OSPF routers decide how to forward traffic through the network based on the cost of a path, right? The least expensive or shortest path wins. All OSPF routers in a local area see the network the same way, do the math in the same way, and converge on the same path through the network. And if that shortest path is slammed full of traffic and there happens to be an alternate path carrying nothing, OSPF can't help you. Get a bigger pipe. PCE gives you flexibility. PCE runs centrally on a controller, seeing the network as a whole, like an eye in the sky. PCE knows more than just network topology, though. PCE knows about what's happening on the network, assuming you wanted to know that. For example, PCE can be told how much traffic is flowing across a specific interface in the end-to-end path. And using that information, PCE can decide to forward some traffic through an alternate path that's less busy. Now, PCE has lots of use cases. To help us understand PCE in more depth is Andrew Stone. Andrew says that he lives between the two worlds of being a networking/routing person and a software development person, and PCE is one of his knowledge domains. So, Andrew, welcome to Heavy Networking. It's great to have you. And would you tell us in a sentence or two who you are and what you do?
Yeah, so first, thanks a lot for having me on. I'm really happy to be doing this, and I love the show. So, like you said, my name is Andrew Stone. I work as a software architect for Nokia. I basically in university studied network engineering, and I managed to actually operate on a fairly large enterprise network all through university. And I kind of ran into that little bit of a roadblock where it was, do I want to go the network engineering route, or do I also want to go the software route? Because I just always kind of really loved coding. And so I kind of got fortunate that I found a job position with what used to be Alcatel-Lucent and working on control plane products. So for me, that was actually kind of the best of both worlds, that I get to apply the networking and then also get to write code and figure out how software is developed and built and deployed. So my main focus for the past quite a while now has been really in the PCE and control plane assurance and software controller based applications.
Very cool. All right, man. So I know you know a ton about PCE because this is your world, one of your major knowledge domains and places you've written a lot of code and so on. Well, we got to set this up for the engineers in the audience because many of them listening here are going to be enterprise focused. They likely know OSPF. Maybe they know EIGRP if they're a Cisco shop. Maybe they know some ISIS, a bit of BGP. Probably not a lot of MPLS, and almost certainly not PCE for those folks. Would you explain to the average enterprise network engineer in simple terms why PCE? What problems does PCE solve that traditional routing cannot solve?
I guess at a high level, it's all about traffic engineering. The simplest way you can think of it is, I've used Google Maps at peak time at rush hour. You want to get from point A to point B. You want to get there quickly. Maybe you don't want to take a toll road. PC kind of lets you do that, but it really takes it to a whole other level where you can do really complex traffic engineering because, as you know, OSPF, ISIS, every router learns how the topologies interconnected. They make their own decisions. So if you and I make our own traffic decisions, we end up on the same highway, we create congestion. Or maybe we have rules, like if I want to go on a road trip, I want to make sure I take a route that follows some kind of characteristics. Well, the routers, certain times they can't enforce those types of characteristics. And so PC is really about enhancing the path computation. It's about taking what you do today with normal routing, pick shortest path, but really bringing it to more complex traffic engineering rules. And when you start to do that, you really end up in this picture where there's a centralized brain that's kind of taking control of everything and deciding where to place all the traffic. And so rather than having this distributed, decision making, it's centralized. Get to make better decisions.
And better decisions because we can take telemetry in from the network in real time and use the real time state of the network to help us make decisions about how to forward now.
Yeah, exactly. I think there's the two sides to it. There's you get more insight, you get more information. In the case of, like you mentioned, OSPF ISS, multi-area, multi-level, multi-instance, multi-domain. In a normal traffic engineering situation, routers don't really see outside of their flooding domain. Whereas PCE can learn every single flooding domain, stitch it all together. Now suddenly you can do traffic engineering end to end. So there's the telemetry side of it. And then there's also it's got more information. It can do more decision making that you can't do independently. And so one really kind of popular use case actually that PCE really helps with is bidirectional co-routing, right? I want to have my traffic from A to B, and I want to make sure that when traffic goes from B to A, that it follows a symmetric path. Normally, it's just shortest path in each direction, and traffic kind of flows wherever the shortest path takes it. Troubleshooting, it's a nightmare, latency, delay, jitter, right? All of these characteristics kind of come together to say, okay, well, compute me a path with these characteristics, but do it up here in a brain rather than down here in the network. And sorry, go ahead.
Yeah. Is this aimed at primarily like service providers and telcos, or is this also for particular, large enterprises that might have traffic engineering needs?
In general, it'd definitely be a service provider kind of world. It's really, really, I'd say, prominent in the WAN. I mean, there's always that open debate of traffic engineering in the data center, right? The applicability of TE in the data center, I don't think is quite there yet. We'll see as time goes on. So mostly we're talking about large WANs, so service providers. And I mean, the whole service provider enterprise discussion, I know obviously on the show, there's been that discussion of where does the enterprise line get drawn, right? And so utilities operate fairly large WANs and they're running their own network. And they might be running, and you mentioned earlier about, listeners might not know about MPLS. This kind of world of PC is very much dominant in MPLS, traffic engineering, and then of course now with SRv6 as well. So it's kind of in that kind of space. It wouldn't be in your classical enterprise branch kind of environment.
And another basic question, since this is controller-based, I'm presuming the person using PCE owns all of the routers that are in whatever a PC domain is called.
That's actually, we'll probably get into that when we talk about the PC components. In general, yes, but ownership becomes selective. You might have a company where one domain is owned by one team and another domain is owned by another team or another subsidiary of the company. And so there's ways in PCE that can kind of deal with that. Hierarchical PCE is one of those aspects. But traditionally, yes, I'm running my network, I'm running my routers. I have a PC running in the network and it's managing that domain.
Yeah, you mentioned the other fundamentals that there's some, I think, 3 components that we need to understand to know about them: Path Computation Element, Path Computation Client, and Path Computation Element Protocol. Can we go through those?
Yeah, no, definitely. So right off the bat, PCE, Path Computation Element. It's interesting that, it was mentioned that PCE is running on a controller. The actual IETF RFC that defines PCE actually doesn't mandate that. I would say most implementations have moved into a controller-based deployment, but the actual original RFC or the architecture is essentially can run anywhere. It can run on a router, it can run on a piece of software somewhere, or as a comprehensive controller suite. And so Path Computation Element really is the server that's operating like kind of your brain, right? It's taking in the information and it's computing paths. And even that mode of being a PC in the IETF architecture, there's actually 2 flavors to it. One of it is known as a stateless PCE, where you're not remembering anything. So it's kind of like you go to Google Maps and you say, hey, find me a path. PC replies, and then it forgets about it. It doesn't remember what you want. Purely kind of read-only, passive kind of ask and respond mode. That's how PC was originally kind of architected. And even that original architecture, I mean, for anybody that might be familiar with PC, or if you're Googling it right now, this is not new technology. I think it was like 2006, 2007 when that became RFC. However, that PC architecture evolved into a stateful PC. And what we're really talking about here is you're actually remembering decisions. You're learning about state, like the traffic engineering paths. You're learning about it. You're keeping in sync with the network. And that's when it really starts to become more of a controller-oriented solution. And the PC itself, when it's stateful, it can become active, as in it can proactively make decisions. So we'll probably talk about it more later about, telemetry-based optimization and congestion avoidance, those kind of topics. It's really a stateful PC that goes and says, I'm looking at the network. I see something going weird here, or I see something suboptimal, right? Because we have traffic engineering rules. I see something suboptimal. Let me go and move stuff around without any human intervention. I'm just going to proactively move things around because my policies say you must follow these types of SLAs or these characteristics. And I would say that form of PCE is probably what's more prominent today, right? That controller-based, running centrally, being active, trying to essentially manage, where the paths are in the network actively. And so that's the PCE. I could see a question coming up on there.
Well, the term element. So back in the days when I was learning SNMP, probably 30 years ago, the term element would come up as in an element. It's a port, it's a router, it's a thing that you are managing with SNMP, and the term element kind of referred to something more or less physical. Does Path Computation Element have a definitional mapping like that?
It's interesting because the term element is in there, and then some of the RFCs specifically reference it as an entity. So it's a thing. It's a thing that's sitting somewhere, computing paths for you. Whether it's a process running on a router, whether it's a piece of software running on a VM, or whether it's a container running on Kubernetes, running in your data center. It's a thing that's running somewhere that computes for you, that learns topology information, and it computes for you.
Okay. So then what then is a path computation client? Something talking to the element?
Exactly. So a router would be a good example as a client. Now you might ask yourself, well, how come it's just not called, a router, right? As opposed to a client? Because there's some other interesting kind of architecture components of PCE, which is PCEs can talk to other PCEs. And so there's architecture models for hierarchy where a PCE might only actually learn or manage a certain part of the network for whatever reasoning. So client is really that generic term to basically let you say, well, it's a thing that's asking a PCE or informing a PCE about certain things. Like, here's my latest state.
So a PCE could also be a client.
Correct.
Okay.
So the distinction between PCE versus PCC, that client, is really just that server client delineation. But generally the PCE is, I'm computing for you, and PCC is the thing that's getting told the information or sharing the information.
So then Path Computation Element Protocol, this is the language they speak. This is how we marshal data and exchange information. That's what PCEP is defining for us.
Exactly. And somebody might go, well, what about netconf? What about BGP? What about, it's another protocol. I would probably equate it very similar to, let's say, gRPC. But of course, PCEP, PCEP, or Path Computation Element Protocol, was designed way before gRPC even existed, right? And it's designed specifically for PCEP, right? It's our PCE. It's designed specifically to carry traffic engineering information, can carry hop information, signal the state of this information. So it's very efficient, but it is yet another protocol. And so it's actually, you mentioned at the start about, some people might know about OSPF, some people might know about ISIS. Those don't go away, right? Those still exist. BGP is still running here. And we'll probably talk about BGPLS at some point. And those, your OSPF, your ISIS, your BGP, those still remain. PCEP is another protocol purely to let PCE and PCC communicate with each other and provide information back and forth.
How widely supported is the Path Computation Element Protocol on your various router OSs?
I would say probably in the past 6 years, it's been pretty widespread on most major vendors. Stability for interop. There's been interop testing that's been going on for at least 6+ years, 7 years now. So stability is quite there. It's quite mature. It's typically on your service provider oriented routers, right? I wouldn't say it's on your branch router, probably might not have it, but if you're running MPLS, chances are it probably has an implementation. And then of course there's multiple vendors that have implementations of PCE. So that is one kind of interesting characteristics of this, is that your router might be one vendor and your PC is a different vendor. And that interop and that capabilities do exist.
Okay. We talked about PCE as a controller. It needs to learn the topology. I'm assuming this is why ISIS and OSPF exist. You mentioned BGPLS. So talk us through that.
Yeah, so it's for Google Maps, right? And it's always the easiest comparison. For it to obviously compute where you're going to go, where you're going to drive, it needs to know the road network. PCE needs to understand the road network. It needs to understand your topology. And so I'm sure listeners probably, when they continue listening to this, they're going to say, hey, what about optical? A little caveat, PCE is really supporting traffic engineered tunnels, traffic engineered paths. That can be IP, MPLS, SRv6, or also optical domain. And to be honest, my background in optics is very minor. So a lot of my viewpoints will obviously be skewed towards IP, MPLS. So in an IP, MPLS deployment, BGPLS is really the protocol used to learn that topology, to learn that road network. And that network that it's learning, that topology, is OSPF or ISIS.
And BGP is not a link state protocol. If I remember, LS was an extension added to BGP for this purpose, right?
Yeah, correct. So it's that mantra that BGP is really, really good at distributing information, right? Errant to multipoint. It's fantastic for it. In this case, it's not like OSPF where it's exchanging routing information to make routing decisions, or it's not exchanging BGP routes to make routing decisions. It's actually using BGP as a transport to carry the link state information. So you have your OSPF or ISIS running in the network. One of those routers in a given flooding domain, ideally 2 or more for redundancy. Basically, you're taking a copy of their link state database. And so rather than go to the router and try to download their link state database and keep in sync with it, there's a high probability that router has already got a BGP stack running on it. And so BGPLS is a way to take that link state database, feed it into BGP, and use BGP as a transport. And it just basically sends up the information as BGP routes, but they're not actually changing the forwarding of your routers. It's simply providing information to a consumer. And one of those consumers is PCE, or it could be PCE.
Okay, so PCE can consume BGPLS information and help it discover the topology of the network as BGPLS sees it. But also we could PCE could talk to OSPF or ISIS and inquire about the topology that way?
Yeah, so there's some challenges, obviously, with probing into the link state database, right? You could statically configure it, right? There's ways to kind of teach PCE the topology. But in general, the kind of recommended guideline I would say would be to use BGPLS because you're in sync with the link state topology. So link goes down, you get a notification right away. And because it's being transported with BGP, it's a TCP connection. So if your PC is running in a data center somewhere on Kubernetes and you've got your network running in your WAN, it's just a TCP channel, very similar into your kind of management plane. Not quite management.
Like what you're saying is BGPLS is how it's done. Is that fair?
In the IP optical, or sorry, PMPLS realm, I would say that's a fair statement. Yeah.
Okay.
And it's nice because you don't have to be tapping into the network. You've kind of got this probe that really exports this topology information for you and streams it up to you with BGP, right? So you get all the route reflector mechanics that BGP gives you, all the redundancy. There's RFCs in the IETF that talk about, how do you handle all of these messages? So the multi-vendor interop as well there is also very stable.
We talked about the fundamental architecture, and you said there's a central controller and so on. So again, piecing all this together, I've got software running on a controller. I've got something that's running on a router that's a client. And then are there more pieces to this? Are there other outlying PCE components that are doing computing scattered around, or is it more of a controller, bunch of clients that I'm talking to?
So actually there's probably a couple parts of that. In terms of, I would call bare bones simple PCE, it's exactly like you described. You've got a router, it's running as a client. Notifies to PCE, hey, please do some stuff for me, right, with these tunnels. PCE is learning topology with BGPLS, and it's pretty straightforward. I think where the real kind of production deployments come in is obviously redundancy. So you need to have, for example, backup PCs, or maybe your PC implementation is high available, or maybe it's got disaster recovery mechanics to it. You need to have multiple speakers. And then to get into those use cases that we talked about with telemetry and really understanding some live information about the network, you might also in parallel be running gRPC. So all of these kind of protocols all come together in a fully production-wide deployment. I would say, yeah, you're going to have PCs, you're going to have backups, you're going to have redundancy built in. Your You're probably going to have a route reflector for your BGP with your multiple BGP-LS speakers. gRPC is probably running in the mix, and the PCE is kind of sucking all this information up.
Okay, so with that architecture in place, now let's get to how do my PCE traffic engineered paths get jammed into the FIP? I mean, if I got a routing protocol, I know how that works. I go from RIB, and we sort it out in the RIB, which is going to be the correct forwarding path, and jam it into the FIP. How does PCE basically preempt? Assuming we're going to preempt everybody else and get that entry in the FIP.
I wouldn't use the word preempt here, but yeah, like in general, these tunnels, right? I'm being very vague here with the term tunnels, just because there's different kind of tunnels, right? You basically, in a stateful PCE model, you would define these tunnels, and you would typically, for example, go to a router and you would create your tunnel, whether it's an RSVP-TE tunnel or a segment routed tunnel with MPLS or an SRv6 tunnel. You'd configure it just like you normally would, right? There's nothing special there. You'd say, oh, I'm creating a tunnel from A to B. The PCE involvement here now is you have to decide, am I just informing PCE about this? Or am I asking PCE to compute this? Or am I giving control to PCE to take over this path? In all cases, at the end of the day, PCE gets informed this information using PCEP. Mm-hmm. At this point, PCE computes, and PCE using PCEP replies down to a path to the router. Or we actually call it an update. It updates the router for that LSP or for that tunnel. And it says, here's your qualification. On the router is my PCEP listener basically a daemon like a routing daemon would be? Yeah, I think that's a fair way to describe it. It's another process. It's, if you were to think the components of a router, you'd have your OSPF daemon, you'd have your BGP daemon, you'd have something doing MPLS related work, something doing segment routing related work. PCEP is another block in that architecture. And so, but it ties really much in with the tunnels. And so you've got these tunnels, and you basically say, hey, PCE, here is my tunnel, do stuff for it. And the end result is PCE says, here's your series of instructions, here's your hops. Or specifically, we call it an ERO, an explicit route object. So rather than the local router do all its own computation, right, look into its graph and figure out what is the path from point A to point B, it says PCE, you figure out the hops for this tunnel. You figure out the path for this tunnel. So from a router's perspective, whether PCE is in the mix or whether its own local computation, it's kind of independent. At the end of the day, it gets a series of hops.
Is the PCE daemon on the router directly pushing entries into the FIB, or is it informing another daemon, like a traffic engineering daemon, let's say, where the tunnels are segment routing? Here's a label stack, and then that process. This is a subtle distinction. I mean, I'm not thinking too hard about this, but
it probably depends where those implementation cutoffs will be. Because even with label stack, in the case of segment routing, is it a node SID versus is it just an adjacency SID? How does that label stack get programmed? Is it consulting something else? I think that's where that implementation details might come in. But in general, it would be exactly you said. It's a label stack. So PCE informs the router, here's your label stack for this tunnel. In the case of it's MPLS, right? It's labels. In the case of SRv6, it's SRv6 SIDs. There's actually another interesting side to this, which I didn't comment on because I figured we might get to this, was that what I just described is known as PCC initiated, right? The router starts the process. The router says, hey, here's a tunnel. Please do stuff for this tunnel for me with some characteristics. The other way is what's known as PCE initiated. In that case, you don't go to your router and say, I want to configure a router or configure a tunnel on the router. I actually go to my PCE to do it. So there's no config on the router. I go to my PCE and I say, to program this tunnel on this router with these characteristics. And what happens there is that using PCEP protocol is it actually pushes down a tunnel and the instructions for the tunnel down to the router with no config, purely state. So it's a different paradigm. And so if you go from that whole, is it SDN or is it controller oriented versus network oriented, right? There's this here. Yeah. And it depends what use cases you're doing, what problems you're trying to solve, what problems you want to avoid. And the other kind of interesting thing is when you start to do stuff that involves this, you can start to get a lot more automation in it too as well, right? Whether it's the router creating the tunnel automatically or whether it's the controller creating these tunnels automatically. You could have situations where triggers happen that cause the need for a tunnel to appear.
So, can you compare this to OpenFlow? You remember the OpenFlow model from back in the day?
Yeah.
So the parallels worth drawing here?
I didn't have the joys to actually work on OpenFlow, but obviously I've looked into it. I'd say the comparison probably would be at the centralization aspect. And I'm sure most listeners are probably like, centralized doesn't work. It must be distributed, right? It's a fair statement to make. But I think where PCE kind of draws that distinction is it's not necessarily purely centralized. What you're doing is you're centralizing path computation. You're not necessarily removing the capability on the routers, right? So the routers are still running OSPF. They're still running ISAS. They're still running BGP. They still have capabilities. They're not quote unquote dumb. They're not simple. They're not. And on top of that, they can still make their own decisions. The distinction here is that they're kind of delegating, and that's actually a term in PCE, they're delegating responsibility to a PCE, but they're not necessarily reliant. Like if PCE dies, it's not like the network goes down, right? Things still can live on. You can still have fallback mechanisms. So for me, when I look at PCE versus something like OpenFlow, you're not installing instructions for specific flows. All you're doing is you're providing hops for tunnels. Now, it sounds really simple, but of course, why you're providing hop A versus hop B, that's where the magic comes in. But you're not necessarily doing full data plane steering. You're doing tunnel path routing. You're not removing all the data plane capabilities of the router or the other control plane capabilities of the router. You're kind of augmenting it. You're kind of enhancing it.
So you, I think, addressed one concern folks have with, the centralized mechanism that if the controller dies, traffic will still flow and the routers do still have some autonomy. Are there situations, or is this common, where some of the traffic is relying on PCE for being put into tunnels and some traffic I'm relying on, OSPF or BGP to get traffic to its destination in its same network?
Oh yeah, definitely. Even in the case of, every network's a snowflake, the typical thing, there's a lot of brownfield networks out there. We're not very fortunate often to go on greenfield networks. So you might have networks out there that are still running LDP. They might be running RSVPT. They might be running just native segment routing, and they want to bring PCE into the mix. Or maybe they want to do migrations between one or the other. Those things can still remain. And so it's kind of up to the operator to decide, okay, well, I want to bring PCE in my solution, my network, because I want to do some kind of traffic engineering. Which tunnels am I really going to give control of, or which tunnels am I going to bring PCE to? Is it going to be my really important traffic that I want to have certain characteristics or SLA on, or is it my non-important traffic because I just kind of want to punt it out of the way, whatever that might be? That's totally up to them, and they can introduce that kind of slowly as needed. It's not you don't have to forklift the whole network. You can do it on a per tunnel basis, and you can get those improvements even for just that subset. Obviously, the more you give PC, the better your outcome might be, right? Especially when you start getting into telemetry optimization. But it's not a one and done. It's really, you can kind of trickle it in. And then what happens when the PC dies? Well, first off, hopefully, you have redundancy, you have high availability, you have DR, you've got all these extra protections in place. But in a worst case scenario where you decide, look, I don't like the behavior that's going on, I want to pull back for a minute. I want to reevaluate what's going on here. But you can still fall back to the router doing its own routing decisions, just like you do today. Or whatever mechanisms you do today, that's still available. Obviously, maybe it's not optimal, but it's still available. So that really kind of gives, for me at least, it gives the less of a scare of what happens when my brain dies. Well, your network doesn't die. I kind of got this rule: the packets must flow. The packets need to flow. Maybe they're not flowing optimally, but they must flow. So.
You said that PC sees the network end-to-end and knows the topology. It's going to program different paths for different source and destination combos via a tunnel. All right. You've been intentionally a little vague about tunnel because it depends. Can you put some meat on the bones of tunnel? What kind of protocols are we talking about to make up these traffic engineered tunnels?
So I'll maybe the first side, the very lean meat, tunnels could be optical, of course, and that's the lean meat of it that I'm not very...
Basically, over. So layer one mapping, connecting a light path end to end.
So that's the first side of the world, which just that sits at the corner. And then from an IP MPLS, what we're really talking about here is MPLS, so RSVPT or segment routing with MPLS, or independently SRv6. And so, of course, with MPLS, it could be IPv6, IPv4 network. In the case of SRv6, it's a IPv6 network. And it's really those protocols that do signaling, right? And I'm using the word signaling here very loosely because obviously with segment routing, there is no signal other than the IGP, SID distribution. In the case of RSVPT is still running. There's still signaling in the network, right?
Because we're reserving bandwidth along the path.
Depends, right? So in an RSVPT kind of PCE solution, you could reserve bandwidth along the path in the network, or you could just leave that intelligence to PCE and not actually signal bandwidth in the network. So this might be a bit of imagine you're using live telemetry. Well, if you're using live telemetry, whether it's with RSVPT or whether it's with segment routing, from a PCE perspective, if it sucks up all the information and becomes that brain, it actually doesn't matter too much. But the hops are still being signaled, right? So with RSVPT, you're still doing that hop signaling. You're still doing that label reservation. As opposed to with segment routing, you're providing a label, the label stack, as opposed to providing a path. And so there's some subtle differences between what happens on link failures, right? With RSVPT signaling can detect the failures. In the case of segment routing, BFD would have to be used to actually detect failures. But at the end of the day, from a PCE perspective, it's still computing hops. It's just what those hops actually do on the router, whether they're signaled or whether they're label stack encapsulated. That's where there's that difference.
Our sponsor, Meter, is a network as a service company, and that means a Meter network is a tightly integrated stack of network hardware and operating system software, delivering wired, wireless, and cellular service. Now, Meter delivers the gear to your premises as a service, right? And what that means is the tedious parts of network operations are handled by Meter for you. So you don't have to deal with NOS upgrades. When gear hits end of life, they're going to send you shiny new gear, all of that, and they monitor your network for you remotely. Meter can handle sites as small as a branch office and as large as a campus or data center. Meter doesn't just ship gear to you, though. They handle other aspects of bringing a site online. They can deal with internet circuit procurement and site surveys and cabling. All of that stuff and more is part of what Meter offers. The network stack that they're delivering gives you a full function, all the things: security, routing, firewalling, switching, wireless, cellular, power, that is intelligent power, DNS security, VPN, SD-WAN, and even multi-site workflows. In fall 2025, I did video in the Packet Pushers YouTube channel where I work with a Meter stack to show you some of those features. And I'm going to do an updated video in 2026. I was at their headquarters recently, and I got a sneak peek at their newest hardware and a preview of the new software features. There's a lot of stuff coming. These guys are iterating fast. And how do I put this? There's a vibe. It's been a while since I visited a startup I had that genuine thrill of enthusiasm from everybody that I was talking to there, but I got that at Meter 100%. The Meter team is excited about what they are building. So thanks to Meter for sponsoring, and go to meter.com/heavy networking to book a demo. That's meter.com/heavy networking to book a demo now.
So is PCE introducing yet another encapsulation mechanism, or is it relying on segment routing or MPLS and just drafting on that?
Yeah, it's completely relying on the existing protocol. Even in your show commands, right, on your typical router vendor implementation, you show me my tunnel, show me my RSVP tunnel, or show me my segment routing tunnel. The show commands are all identical. The only difference is it might say, oh, this is my stack, or this is my label, or this is my ERO, or this is my RRO. Oh, and by the way, it was computed by PCE. But the actual data plane signaling, it's all the exact same. Right? It's as if you almost as a human went in and said, I want you to take path, A, B, C, D. Well, it just so happens that it's a PCE doing it with a lot of rules potentially, right? Path diversity, path protection rules, bidirectionality rules, telemetry awareness, delay awareness, packet loss awareness. It grows, right? All of these different characteristics.
So can you then, I guess I'm feeling a little confused about how PCE differs from something like segment routing. What is it? Because segment routing is essentially doing the same thing. It's setting up a tunnel for me to get traffic that I sort of choose based on different parameters to get traffic from A to B.
Yeah, so no, that's fair. So even the segment routing, there's obviously the two sides of just kind of native segment routing where you're running with ISIS or OSPF. And then there's flex algo. I would say that the native segment routing with ISIS or OSPF, you're doing shortest path, right? You say, create me a tunnel from A to some destination. It's going to follow the shortest path of your IGP. With flex algo, similar concept, but of course with flex algo, you can do stuff like use a different objective, right? You can make it delay based, or maybe you can have, there's some, I call it TE light, right? There's some minor TE you can do in there like admin groups. So you can set up planes in your network, but it's still a distributed decision making with a very small subset of TE. Whereas PCE, you can still have that running your network, but now with PCE, you could say, look, I want you to compute me a path, but I want you to bring in all of these other characteristics. I want path diversity between other tunnels. I mentioned about bidirectionality. I want bidirectionality. So I want to steer the traffic in a certain characteristic on a per tunnel basis. And so even with that encoding, if you think about, native Sigma routing, it's a node SID, right? Pick me the shortest path. Either it's in an alvo 0, which is your native IGP, or it's in another flex algo where it's still the shortest path. Whereas with PCE, it can still use a node SID, but it's probably also going to combine it with multiple node SIDs or multiple adjacency SIDs. Or
the mechanism's the same for how the tunnel itself gets built. It's still segment routing.
Correct.
It's just that the nature of the segment routed path, the tunnel, is computed by PCE via a whole bunch of criteria versus me typing it in by hand.
Yeah, exactly. And that distinction probably really comes down if you use the term just SR or segment routing versus SRTE, segment routing traffic engineering. And so SR gives you obviously the IGP distribution of your SIDs, your node SIDs, adjacency SIDs, and so on. SRTE is really about using those SIDs to traffic engineer your path, right? Go off the shortest path for some reason, whatever that traffic engineering reason might be. But the data plane is all the same.
So talk to me about the role of the network operator once baseline PCE has been configured. Do I hand over forwarding for the whole network to PCE? Do I interact with the PCE controller software? Am I setting policy? Am I monitoring things? Am I reacting to problems? Or is PCE basically set it and forget it?
I would say probably the first start is install it, right? Run it, configure it, set up the protocols. And then a lot of the implementations provide a UI, right? They let you see what's going on, whether it's a topology map or it's an inventory list of your tunnels or your links, your routers, your prefixes, and so on. So most kind of deployments, I would say they actually start off in a visualization mode. So you would deploy...
The PCE is not building tunnels for me. It's just giving me this interesting view of the network.
Yeah, exactly. So imagine you have a brownfield topology and a brownfield network running. You deploy everything. You go to BGPLS. You say, hey, provide PCE my topology. Purely read-only, purely passive. Now you get a nice, pretty map.
Hey, Bob, did you know we had a circuit in Fairbanks, Alaska? I had no idea. Look at that. It's right there on the screen. Check it out.
That's pretty much it. Or, hey, that link is bouncing, and why does my link go up, down, up, down, up, down, up, down, and so on, right? So it's really good from that starting point, right? That visualization. And even that has a lot of value, right? I remember the first time when I got to see an OSPF topology map. This was a long time ago. And I was like, whoa, this is amazing. I could have used this when I was doing even on the enterprise side. I wish I had BGPLS, 15 years ago. That would have been amazing. But it's probably visualizing topology. And then I mentioned about, you go to your tunnels. If you have pre-existing RSVPT or segment routing tunnels, you configure them. You control what you want them to do from a PCE perspective. And one of those options is just report them. That's what it's called in PCEP, is just report the paths. Provide state to the PCE. So you go to your tunnels, you turn on reporting. Suddenly now these tunnels show up in your PCE. You can see them. You can see what path they're taking. You know if they're up.
Because my clients are telling the controller about that. I've already configured my routers, my clients, to talk to the controller.
Yeah.
And be able to share that information.
And so now you've got insight. Now you can see like, hey, let me choose my primary path and my backup path. Let me highlight them. Let me see where they're going. Let me visualize it, right? That's kind of, it's an insight to kind of see what's going on. You could take that one step further and turn on gRPC, get telemetry for it. Right. So now you can do in a purely read-only mode, see how much bandwidth is going across those tunnels, how much bandwidth is going across my links. Just visualize it. No actions, no decisions, no nothing. I would say these are probably the starting points. And then once you're kind of like, okay, I'm cool with this. I want to actually, do what I just paid for. I want to make PCE do stuff. I want to make it compute things. At that point, you would select what do you want it to compute? What are your policies? What are your rules? Some operators care about path diversity, right? Like I mentioned. Is it link diverse? Is it node diverse? Is it SLG diverse, right? Which one of those do I care about? Do I care about bidirectionality? Maybe I do, maybe I don't. Do I have other characteristics like delay constraints? Even what do I want to optimize on? Do I want to use the IGP metric while I'm computing the best path? Or is it delay? Or is it some other kind of objective that's proprietary to the controller?
It reminds me of some of the policies you can build with SD-WAN, which aren't standardized. That everybody's got their own way of doing it. But you can specify, I need a tunnel that gives me these characteristics so I can push this sort of traffic across it.
Yeah, exactly. And even obviously there's a lot of standardized encodings that exist inside of PCEP. So for example, all these objectives, IGP metric, P metric, delay, all of this is standardized. But once you start going into that centralized brain, you can now start to do some more stuff in this central piece that you don't need to deploy to the rest of the network. The network doesn't have to care. Maybe your controller understands dollar value, right? I'm just throwing it as an example. Network doesn't understand dollar value, but my controller understands dollar value, right? Or other...
As in, I could make a routing forwarding decision based on the cost impact to my network because it costs me more to send via this provider than this provider.
Potentially, yeah.
Time of day, yeah.
And so these types of policies and rules, there's a bit more as well that might come into the mix. Like, for example, with segment routing, do I need to use binding SIDs in my solution? That's another piece of the pie that maybe PCE can help out with. It's really about changing the behavior of the computed paths. So deciding that is really a key thing, right? What do you want to do with PCE? That's really a fundamental question that only an operator can really answer. Once you've decided that, okay, then now you can go to your tunnels and basically either attach these policies or rules, either on the tunnels themselves or on the central, PCE itself, and then turn on control or turn on delegation. So I did mention that, at the start that there's the stateless versus stateful. I would say most operators just immediately go to stateful, which is you just, hey, PCE, take care of this LSP, take care of this tunnel, make sure it does what I want it to do, right? Whatever those rules might be. And that doesn't have to be network-wide. You might start with a certain small part of the network. You might start with a selective type of LSP. It's really up to kind of you. And then as you start rolling out, suddenly now network-wide, all of your PALs are under control of PCE.
So, yeah, go ahead, finish.
Oh, no, I was just going to say, and then once, of course, you've got it all delegated, at that point, I just say it's autonomous, right? And I'm using the word autonomous here very cautiously because exactly. But it really is because, like your OSPF, right? If you think about OSPF or ISIS, you configure it and it runs, right? For the most part. Links go up, links go down, it recomputes, it forwards differently. It's not, you don't really need to handhold it per se. PC is kind of very much like that once you've got your rules how you want.
The policies are more complicated.
Correct. It's not just shortest path, it's more. So it's hands off in the sense of, okay, it's running, it just will do its own thing. It doesn't necessarily mean you can ignore it. So I'll give you an example that's kind of a funny one, right? Delay-based routing is quite popular, right? For good reason. But it means you're now going to be routing off of delay. If your network has mixed bandwidth capacities, maybe you might start taking links that it's the shortest delay, but there's only so much capacity on it. And so if you're choosing policies like delay-based routing, you likely also want to consider what is my bandwidth constraints on this as well. Right? Do I need to bring telemetry into the mix? Because doing delay-based routing is straightforward. Doing delay-based routing to make sure you don't create congestion along that shortest delayed path. Same thing as the shortest path problem, right? But now it's different. It's not, your typical engineer might be looking at your ISIS or OSPF and saying, okay, I can see shortest path by my IGP metric. Well, delay is a little bit, it's another metric at the end of the day, but it's still not obvious sometimes. And so if those policies or those rules like delay, maybe you also want to bring in bandwidth in the mixture. If you're doing diversity is great, right? You want to have your backup paths that are being diverse. Well, how many backup paths do you have in your network, right? How much variability do you have in your network? Because you end up with link failures and you tell PCE, make sure these paths are diverse. If you have a link failure and there isn't enough, variability in the network to carry that diversity, well, then things will go down, right? So you do have to consider about, I've configured these SLAs, I've deployed them, I can go hands off, but I still want to revalidate them to make sure that, they're behaving how I want them to behave. And maybe I might need to tune a knob, right? Maybe I might need to change a certain kind of detail on what, maybe I need to relax things, right? It's really up to what it is that you're actually trying to accomplish with it. But in general, you just let it run.
So my understanding that one of the values here of PCE is that I can set up tunnels based on a whole variety of conditions and policies and, service level outcomes. So how does PCE get the information about the network to apply those policies and rules to give me those outcomes?
Yeah, so let's just mention about delay. So delay would probably be the easiest one to start with. So for example, Twomp Lite would be running in the network. If you wanted really live measurements on, your per link basis. So Twomp Lite's running on the network. PCE.
Twomp's open source software takes measurements across I did a show with Nick Baraglia.
Yeah, I remember
who's
Yeah, so Twomp, I think I listened to that one too. And in that episode, if I recall, I think he was learning Go at the time, or he built something in Go. It's slipping me, but Twomp itself actually it's a protocol. It's an IETF standard. So it's how you do delay measurements. Right? You can put it on a router, you can put it in an application. It collects delay. So it's so you'd probably be running Twomp on your network, and then BGPLS and the IGPs actually, for example, for Flex Algo to even do delay-based routing, it's been extended to let you carry delay information. So the PCE can actually learn delay on a per link basis from the topology using BGPLS, right? So it's very multi-vendor, it's very seamless, it's very simple. That's from a delay side. From a bandwidth side, there's actually multiple different kinds of bandwidth. Right? There's the bandwidth that somebody might have requested. I might have gone to my CLI and say, hey, please make sure, this tunnel has this kind of requirement. Or the opposite is, here is the live traffic that's running through that tunnel. And in that case, you're typically going to gRPC. And so the PCE uses gRPC. And this isn't, using the gRPC side isn't actually a PC standard. This is when you kind of go more into the controller-oriented solution, where the controller is going to use gRPC, go down to the router and say, hey, give me byte counts on this tunnel, and learn those byte counts. And from there, it knows, okay, well, this tunnel might have requested 0, right? Maybe nobody configured bandwidth on it, requested 0, or maybe they requested some kind of bare minimum. But the live throughput, gRPC is telling me, X amount of gigabits per second is running through it. Now, that's one side of the bandwidth. And then the other side of the bandwidth is you've still got links, right? You still have interfaces. Now you might think, well, hey, if you have all the tunnels, doesn't that tell you all of the traffic that's going through the links? Not necessarily, because you might still have native segment routing running. You might still have native IP traffic running. You might have LDP running still, right? You might have non-reported or PCE informed LSPs. So I tend to use the term phantom traffic. You might know all of your tunnel bandwidth, but on a per link basis, you might not know the phantom traffic, the other stuff that isn't being reported to PC. And so by going on a per router basis, on a per interface basis, you can go and say, all right, well, how much IP traffic is going through this interface? Or how much MPLS traffic is going through this interface? So that again would be using gRPC. So the controller would basically pull in now, and it can build a picture. Okay, I know this tunnel is going across, link ABC, the link between A and B. I know my LSP is inducing that bandwidth, inducing that traffic on that link. Maybe my LSP is using 1 gig per second, but the interface has 1.5 gig on it. Okay, there's 500 meg of other traffic that I don't even know about. But the key thing is it can understand and see, okay, this is actually how much is really being used on this link right now, live. And
this is all real time. So, I mean, we're expecting the PC controller to be able to take in lots and lots of live telemetry, real-time telemetry, and react to it.
Yeah, and even the real time, so there's obviously a caution to that, because, expectations of network-wide telemetry obviously are coming in the mix, where how live is it, or how real-time is it? Well, gRPC, most implementations, you can go as low as every 10 seconds, for example. So you can get byte counters every 10 seconds. It's going to depend on a myriad of kind of criteria on the platform and also your network bandwidth that you want to provide to collect this information. In general, I think a good rule of thumb is that typically we're getting this information between every 10 seconds to every minute. It's probably a good, reasonable, real-time live collection, which is still quite significant, right? So if you have a traffic spike, yes, you're not going to see it within 1 second or 2 seconds.
Because we don't need PCE to react to a line going down. We're going to rely on the underlying routing protocol to react to that sort of a situation, BFD, etc.
Yeah, so even in the whole failure domain, so the 10 second 10 second 1 minute thing would be purely from the telemetry perspective. In the case of, let's say, a port or a link goes down and a fiber cut happens, that happens at the rate of your link state database propagation to your BGPLS propagation. So PCE can learn about a fiber cut in milliseconds. But in general, it's more than 10 milliseconds. It could be up to seconds. In that case, when you have, for the failure situation, you would still have your rapid failure protection. RSVPT detecting it, SBFD running, local LFA would be still applicable for the second routing case.
Pre-computed backup path.
Yeah, it's not to play. You would still have all of those mechanisms in the picture for failure cases. So that would be quick, both on the hardware side, and then PCE would learn that failure really quick. It could react to it quick. That's kind of like a failure situation. In the case of telemetry, the window's a little bit bigger. The window, and honestly, you do want it to have that to be a little bit bigger. So if you think about traffic spikes, if your traffic spikes for 5 seconds, do you really want to have your controller react to that?
Yeah, I was going to ask you about that because I was thinking about it like a car oversteering, right, into a skid. You start skidding, so you steer, and then the car oversteers, you go too far in, and you're just fishtailing back and forth, and you just constantly overreacting to a situation that you actually want to take it, be a little more chill about it.
Yeah, it's actually the car analogy is quite good because I live in Canada and it's been snowing. It's been snowing quite a bit and a little icy out there, and that's exactly it. Driving on ice takes practice, and you can't oversteer. Sometimes you got to kind of let it go with the flow for a little bit, get a feel for things, and then correct. The worst thing you could do is overcorrect. And I would actually say PCE, I wouldn't say it's the worst thing you could do is overcorrect, but it's a risk that you have to avoid. Right? If there's a traffic spike somewhere, you don't want to go, oh my God, there's a traffic spike. Let me react and let me move traffic, around the world. And then some of that traffic spike goes down, and then you go, hey, that traffic's gone down. Let me react and bring everything back because now it's suboptimal routing. So there is that trade-off between real time and ensuring you're, doing what you want the PCE to do versus, hold on, let's pause for a little second. Let's collect more information. Right? Let's see what's going on.
The PCE essentially takes a deep breath and is like, let's see what happens. And then,
yeah, that's usually a safe assumption. We could probably debate how big of a breath that might have to take, right? Is it a multi-minute breath? Do
you program it? I mean, do you set policy on how to handle that?
So there's the gRPC collection and the advertisement. There's configuration on the router. There's obviously the router platforms themselves still have to provide these statistics. So the platform itself might have its own limitations. It might have its own scaling, right? All of the caveats there. But in general, there's a publication interval, right, on that subscription that you could say, I want it every 10 seconds, 30 seconds, a minute, and so on. That's the raw data. What a controller does or what PCE does with that raw data, I'd say that's really up to an implementation. Does it average it out? Does it window it? Does it look for spikes? Does it look for thresholds that get crossed? All of that would generally be configurable on your implementation. And then even how do you react to it, right? If I see a traffic spike, if I have a bunch of LSPs on a link and that link's getting congested, which LSPs do you want to move around? My higher priority ones, my lower priority ones? Do I want to, in some implementations, they inject certain rules to basically change the behavior of some of the traffic. So I'd say that there's the nerd knobs, right, that are available to kind of tune how you want this behavior, because not everybody's behavior is going to be the same or want the same behavior.
Given these requirements for your PCE controller to be dealing with quote unquote real-time data, it sounds like in terms of the actual controller itself, memory needs to be a priority when you're sizing it out and deploying it.
Yeah. Oh, yeah, definitely. How, obviously different, like I mentioned, the PC entity, just computing basic paths, probably pretty light, right, in general. But when you scale up to very large networks with a lot of telemetry data, you're getting into a lot more kind of heavy loaded, deployments where you are deploying a cluster somewhere with a larger footprint, with a CPU footprint. The challenges with scaling that up is obviously fun from an R&D implementation point of view and managing these, but it is feasible, right? We do have these capabilities to basically make software that can deal with this influx of information. And so what the memory cost is, every implementation will be different, but you're not running this on a Raspberry Pi, right, in general. Let's just say that. So it's also not too crazy when you consider the roles and what it's giving you at the same time.
Now, you were mentioning phantom traffic. Well, there's a different. I'm going to make a subtle distinction of traffic I don't care about. I don't need to optimize it. I'm not worried about putting it into a tunnel. In that case, am I still somehow delegating responsibility for that to PCE? What does PCE do with this traffic that maybe I don't care about particularly?
I would say it wouldn't actually act on that traffic, but it cares to know about it. So, for example, if PC is making a computation decision and it says, hey, I want to put this LSP that has 80 gig of traffic through it on this link, and it's a 100 gig link. Cool, I'm good to go. And it goes to put it on that. But if it didn't know that there was actually 40 gig of this other traffic on it, well, you just created a congestion event. So I would say knowledge is really where it uses that information, is it knows that information in order to do these better decision making. Right? So it's not controlling that traffic, but it's being aware of it to help its decisions. That's probably the real critical part of it.
I got to know what's there. Yeah, maybe I don't need to have any specific path forwarding characteristics for that traffic where I'm going to direct it along a certain path, but it does matter for other decisions I'm making that I'm aware of it.
And even in some practicality, like you can't do anything about it. So imagine if you're running LDP network and you decide, okay, I'm going to migrate to segment routing. Well, you're not using PCEP to steer that LDP traffic, right? It's LDP traffic to me. It's following, what LDP does, right? Or even in the same case, if it's just regular segment routing traffic, but now I want
LDP, label distribution protocol, is in. I got MPLS routers that are exchanging label information. I can't do anything with that. The routers have to talk to each other.
Exactly. So it's kind of outside the scope. I mean, you can go into what about using flow and open flow, and that whole discussion to see your traffic with flow instructions. But in general, PCE is really focused on the tunnels on a given ingress and its traffic during that path. But it has to kind of know what's going on the network if you want to make it have good decisions. Now, if your network doesn't have those phantom traffic, well, then perfect. But unfortunately, there's always other stuff that's running in the network.
You're going to say, there's always going to be something.
Yeah, exactly. So it's good to know about it, basically.
How does PCE handle if, obviously, like PCE has domain over the routers that it's controlling, but presumably on a WAN, you're not always going to be able to control the traffic all the way to the destination. Like if I'm hitting a cloud network or an Equinix or something, and the problems in that other domain, can PCE understand that it's like, the things I'm doing here are fine, they're still an issue, but it's not anything I can do anything about? How does it deal with that situation?
I would say it kind of depends how you're steering into that other domain. So there's a technology called BGP egress peer engineering. So BGP EP. I could see the cold face. It's another extension to segment routing and
Somewhere Ivan Pepelniak is.
Yeah, so I wouldn't say that's a classical role of PCE, but it's one way to steer to your egress, right? Choose your egress exit point and kind of pick that.
Yeah.
But in general, if the problem is beyond that, you really, from a PC perspective in general, you wouldn't really necessarily see it. You might see, for example, if there's congestion downstream, maybe your throughput on your tunnels drop down because TCP is backing off or something, right? So you might see a reduction in demand in your space, but you don't necessarily know why.
Okay.
You might be looking, you might do, okay, the demand on this tunnel has dropped. My topology is currently healthy. It's taken the shortest, path. It's diverse. It's bidirectional. Oh, everything's handy dandy. There could be a problem outside of your world, but you don't really see it.
We've been talking about PCE from a traffic optimization perspective. That's been pretty much the whole conversation here. Can we shift PCE and put it into different roles? Like, is there a security role that PCE might play?
I would say depends, I guess, how you would define, security role would probably be my first thing. In general, I would say, like, one, it doesn't look into the packets. It doesn't understand the flows that are going across. It doesn't look into the prefixes. It doesn't understand, why my traffic is going to a certain destination. I would say the closest kind of link or connection is dealing with those congestion events. So if you do get a surge of traffic for some reason, you're getting a DOS attack.
I was just going to say like DDoS.
Yeah, exactly. You're getting a DOS attack. Well, the nice thing is PC, one, it doesn't know it's a DOS attack. It just knows there's a surge in traffic demand, right? I see spikes on my network. I see congestion happening on, a set of paths or a set of links. Well, at that point, PCE can detect that, kick in and go and say, okay, let me smooth stuff out. It's not actually mitigating really the actual attack. It's not actually understanding the attack, but in this case, it would be helping optimize your traffic engineering. So if your traffic engineering is, I want to reduce my congestion points on my network and spread traffic out, right? That whole mantra of, I want to get off the shortest path. Well, if I can get off the shortest path and send traffic somewhere else in my network, it might not be an optimal path to take, but at least it's a not congested path to take. So PC can kind of play that role, but I personally don't see it as a security product, how you traditionally.
So if I'm, I don't know, Palo Alto Networks, I don't build some custom interesting security application that's leveraging PCE to help me deliver the solution.
Not that I'm aware of. So is a safe statement.
That's not how it's architected. There's not. I mean, if we back away from security specifically, PCE is not a pluggable architecture that I can do clever whatever things on top of it and build in some novel solution. That's not really what it is.
I would say that there's Yang models for PCE. So, for example, if you want to expose an API and you want to ask PCE for paths, you could, in theory, build other systems around it that say, hey, I'm seeing something that's happening. Hey, PCE, please compute a path with these characteristics because I'm going to go take action on something. Or, hey, PC, on this LSP, I want you to invoke this behavior now. I mean, you could build those kind of systems and interact with a PCE. Obviously, API is dependent and so on. But it's kind of framed more as it's a module in your network running, as a component, and it's controlling your traffic engineering paths based off your rules. Who sets those rules? Who controls those rules? If that's another component or a human, it's kind of left open.
Can I get PCE in my lab? I mean, I know how to get router images and all that stuff and build a traditional lab. Is there a way I can add a PCE controller to my lab?
That's probably the more tricky point because, like I mentioned, that a lot of there's multiple implementations out there. Right? Pick a vendor out of a hat. I'm sure they've got an implementation. The ones that I'm familiar with aren't necessarily there's some implementations that I know you can just grab your router image and turn it on, right, and you get some basic PC functionality. The ones that do a lot more of these advanced use cases, a lot of them are typically built in part of a wider automation platform. And that typically is not something that you can just Google and download. And so I would definitely say if you're looking at any kind of automation platforms with a given vendor, reach out to them, say, hey, where's PC in your portfolio? How does PC get used? What capabilities do you have? And then from there, they probably try to sort out how to get it running in a lab and so on.
Well, you're at Nokia. Can you just tap Roman Duden on the shoulder and be like, hey, can we be also in the container lab?
I have dreams on that. Probably just best to leave that there. But yeah, in an ideal world, but we'll have to see if that world can appear.
Another question about infrastructure. Since we're talking about lab, but this is also just about potential customers. We talked about, memory is obviously an issue when you're building this out. Are there metrics I would use in thinking about how to size my infrastructure, like number of tunnels, number of rules or whatever, to help me figure out just sort of, back of a napkin what I'm going to need?
Yeah. So it's actually interesting because a lot of vendors tend to specify their scaling capabilities based on the number of, like I said, number of tunnels, number of routers. Number of delegated tunnels would be very different than number of reported tunnels, right? Because you're actually actively computing for. Something that I've also, observed that's really hard to quantify is how chatty is your network. how many times do you have fiber cuts? How many times are you deploying new routers? How fast is your network growing, right? All of the variability, and that is really...
That is things that change the network topology, and how frequent are those topology changes?
Yeah, and even like you mentioned about the type of topology, density in the topology, right? I might have a network with n number of routers, but only one tunnel per router. That's a very different problem to solve than I have less routers, but 10 times the amount of tunnels. Because remember, it's PC is not necessarily operating on, I mean, maybe you can implement it this way, but a lot of the implementations, it's a centralized brain, so it learns everything. And so the number of routers doesn't necessarily matter. The number of tunnels usually matters more, but how you deal with the things, right, that are going on, the distribution of those tunnels, the density of those tunnels, where those tunnels are going, right? Imagine, like we mentioned about a fiber cut. If a fiber cut happens, how many tunnels are going across that link? Is it, one tunnel, or is it X tunnels, right? That will impact the capabilities of PC. And these things are really quite difficult to quantify. And then how often is that link and that fiber cut happening? Is it one big ISIS instance, or is it many ISIS instances? Are your paths going across multiple instances, or is it all local, right? It's all of these kind of devil in the details. So definitely I would say if you're reaching out to a vendor, talk to the vendor, talk to their reps, figure out, this is what my network topology looks like. This is, honestly, a lot of the cases is these are the problems that I'm trying to solve. So in some customers that I've seen is that, they have, for reasons, they have stability difficulties, whether it's power reasons, whether it's fiber cuts, whether it's load, traffic demand. It's quite something when you see a 100 gig link congested, right? Or 700 gig link congested, or 300 gig legs congested, right? And so how often does it become congested, right? Is this an event that's happening once a week, once a day, once an hour, right? So all of these kind of details in that snowflake of a network really kind of come into the picture. But I'd say if you look in any public docs, you're probably not. It's hard to write this down, right? It's hard to quantify this. So
you are going to have a conversation with somebody.
Yeah, it's worth having that conversation. And don't get me wrong, this is not in all situations. There's been some deployments where it's just, oh yeah, it's n number of routers, n number of OSPs, push it and go and move on. It's really depends on, I guess I would say it depends why you're deploying PCE would probably influence it quite a bit.
Andrew, I can't remember if we said or not, but you're involved with PCE at the IETF, right?
Yeah, correct. Yeah, I started being active in IETF 7 years ago, maybe 6 years ago. Fairly active in the PCE working group. So I'm secretary in the PCE working group. And then what's interesting about PCE is that, everything we're talking about here, notice we've kept bringing up ISIS, OSPF, BGP, segment routing, RSVPT, anything traffic engineering related. And so the IETF groups kind of feed into PCE. So I tend to personally kind of float in that world of routing in general at the IETF.
Okay. Based on what you're seeing happen in the IETF with PCE, do you think PCE is mature and or kind of where are we at?
Yeah, I'd say from a maturity point of view, it's like I said, it's been multi-vendor interop for quite a number of years now. There's still these little weird niche things in the protocol, right? In terms of the behavior that we're kind of optimizing on still from an IETF perspective, right? Hey, I've seen this scenario and this vendor implemented this way and this other one implemented that way. Let's clean up the text a little bit. So there's interop, but it's kind of maintenance, I would say. And so there's maturity on the protocol as its core foundation, which is fairly quite mature, but the extensions still happen, right? Whether they're extensions to the protocol to introduce new kind of capabilities, like there's a new one that's related to how do two PCs sync state between each other, right? How do they exchange information? That's the kind of active work that happens. And then those other working groups that I mentioned, like segment routing still gets new extensions. There's another time variant routing has new extension.
So as those extensions and those other protocols pop up, you as the PCE working group, if you will, need to know about those things so that you can maybe implement them.
Yeah, correct. It's actually quite fun because sometimes you'll be in one working group and somebody would presenting something and the solution will do this. Boom, there's PC and PC was taking care of this. It's like, oh, yeah, I guess we'll need to get. Yeah, so it's good because there's the PC fundamentals or the foundation that obviously has work, right? That has problems to solve. And then there's still the feeders that say, well, I want to do this certain thing with segment routing and I need PCE or want to use PCE or I need PCE, whichever. I need to make sure PCE understands this concept. And so those kind of things kind of appear as well. And so it's quite broad. So, and again, not to overlook it, there is still the whole optical world, right? Just to keep reminding that there is the optical side. GMPLS is part of that full story as well. So
cool. So there's a lot going on here. Andrew, this has been a fantastic conversation, man. This has been really good. One of those mind expanding ones for me. I always worked on the enterprise side, never ran MPLS and certainly not PCE at all. Exposed to them, studied them a bit. PCE, very little. Have had some conversations in various podcasts about it where it was kind of like talked about as if we all knew what was going on. I'm going, just smile and nod. Yeah, keep going. This has been a great in-depth discussion. It felt like it was it wasn't a deep dive, but it was like a deep fundamental conversation to really help you get your head around it.
Dipping the toe, but a bigger toe. Yeah,
exactly. So if people want to have questions for you, they want to follow up with you, Andrew, where can they find you?
Probably LinkedIn would probably be the best bet, or my email as well. You can find me on the IETF. So my email is andrew.stone@Nokia. And yeah, if you're at IETF, definitely chat with me there. And yeah, otherwise LinkedIn or email is probably the best way to go. Every so often I get that itch of, maybe I should blog about some of this stuff. And it just never happened.
And then you show up on a podcast, job done. You can just say, hey, I did a podcast with the Packet Pushers guys. Go listen to that.
That's fine. That's it. Just again, proud of me here. It's been a good friendship.
It's great to have you. And while we were having that last chat about the IETF, Drew was digging through the archives and found that we've done Heavy Networking episode 491, Real Life Segment Routing and PCE, and then Heavy Networking episode 795, Adventures in Latency, which was the show we did with Nick Baraglia about WAMP and a whole bunch of other things, right, Drew?
In fact, yeah, Nick is on both of those shows. The PCE implementation we're talking about on the 491 episode is Nick. He built out PCE on the SNet network he works on. So
yeah, it's actually quite. Maybe I'll share this little story with Nick. Actually, Nick's amazing guy, and I was on a call. This was a long time ago before we actually met in person, and he was describing something, and I was like, "Oh, you want longest path? Let's do that." Well, this is a little bit of a joke, but he had some he's always had some really fascinating use cases, and it's like, this could be kind of interesting. It's not something you typically want in your network, but longest path, I wonder. So if anybody's asking for this, that has never got actually implemented, but it was a good theoretical discussion. So.
And if you guys are out there listening and you don't know who Nick Baraglia is, you can hear him every episode of IPv6 Buzz, the IPv6 Buzz podcast. Nick joined within the last several months and is one of the co-hosts there. So you can hear him and get his perspective on all things IPv6. And thank you for listening to the episode today. If you've never worked with or even heard of PCE, I hope this episode whet your appetite. It whet mine. I'm bummed that it's going to be hard to get it into a lab because now I want to get in and play with it. But we'll see what we can figure out. I do love that PCE provides a way to make routing decisions based on whatever I like, at least in theory. If I can feed the telemetry in, I can use that data to design a forwarding path. And I think that is amazing. This episode of Heavy Networking and every episode going forward can be found on YouTube. And I don't just mean an audio game. You can see me, Drew, and our guests in glorious high-definition color as we have our chats for your education and entertainment. Just search for Packet Pushers in YouTube and our channel will pop right up. Like, share, and subscribe. Tell your friends about us. Let your favorite vendor know that they should be a Packet Pusher sponsor. Subscribe to our awesome free newsletters and tell us anything you want us to know at packetpushers.net/follow-up, where automated robots will whisk your message to our private Slack channel. And hey, you're a pretty great person. Don't forget that. Some days are tough out there in the packet mines. We know. Don't let it get to you. And last but not least, just remember, too much networking would never be enough.